Today you are doing page 497. So let me write this, hold on. Page 497, number 1 through 10. Okay, 1 through 10. This is the second part of today's recording of today's lesson. And this is kind of like a mini sidebar. This is dealing with exponent rational roots. So when we do this, what this really implies is the square root of x. Now, when you have, I kind of like to teach it with this. When you have an exponent, this represents the root, and this represents the exponent, okay? Now, what this means is what times itself, two items that equals this, okay? Square root really means what times itself equals, or I should say this right here, okay? And when you have something like this is called a cube root, okay? And what this means is what times itself 3 times equals that. The next one is going to be what we call a fourth root. From after cube root, we don't have any special names. We have square root, cube root, fourth root. And this means what times itself 4 times equals the square root of, the fourth root of x. So, okay. So what they're asking us here is, what is the cube root of 8 to the first power? Remember I said x to the 1/3 root. This is the root, and this is the exponent. Okay? So what times itself 3 times equals 8? 8 to the first power. And that would be a 2 times 2 times 2. So that would be times 2. So the solution is 2, right? 2 times 2 times 2. So on the cube root of 8 is 2. Okay? Now, the next one they're asking is, what is the square root of 16? What times itself? Well, that would be 4. Let's try the next one. What is the fourth root of 16? See if you can figure that one out. Hopefully you chose 2, because 2 times 2 times 2 times 2 makes 16. Right? There's a 4, there's a 4. 4 times 4 is 16. This becomes interesting because we can actually use odd numbers with our we could use negative numbers with our odd roots. So I can do what multiplies to. All right, pause the recording and you try the next 3 on your own. All right, let's check our work. The square root of 81 to the fourth root of 81 is a 3. Okay, the fifth root of 32 is going to be a 2. The third root, cube root of 125 is a 5. Usually they're going to be low numbers, especially if I put it on a test. So if we have a root of a negative number, now what times itself will equal a negative? There is no real root that will equal a negative, the square root of 16. Okay? But when we have an odd root, so if it's to the 1/3 root, right? What number times itself equals negative 27? Negative times negative times negative will equal that. And so it would be negative 3 times negative 3 times negative 3. We can use negative numbers with these odd roots. Okay? Pause the recording and try the next 2 on your own. So number 3, the fifth root of negative 32 would be negative 2. Okay? The fourth root of negative 81, what times itself? 4 times will give you a negative? Nothing. So we would say no real root because you can't take a square root of a negative number. You can take a cube root, but not a square or an even root, a fourth root. Okay? All right, let's try some more. Now check your work. All right. Right, using only a root. This is a lot more of the same. Okay, let's practice some more. And go. The first one is going to be a -2. The second one is going to be no real root because it's even. The third one we can take, I don't know what times itself, -2. Oh, that should have been easy. 32, 64, and 10, -10 on the last one. All right, so again, rules of rational exponents. So remember, the denominator is our root and the numerator is our exponent. So let's try doing 8 to the 2/3 power. Okay, we can do it in two ways. It doesn't matter. I can do the cube root and square. I can do to the 1/3 power. I don't like to look at it like this. But we can, and then square it. I like to do the cube root and then squared. We can take the square first. Let me show you what I'm talking about. I can just separate it, square it first, then take the cube root, or we can cube root it first and then square it. I think I like the first method better, but I actually break it down every time into the radical. So I will do something like this. 9 is the base. It is going to be a square root. Remember, it's the exponent over root. Right? And there's the base. So it's 9, it's a square root, and it's going to be cubed. And I can write it like that, or I can write it like this. Okay, so if I think that this is my preferred way, because I take the square root, which is 3, and then I cube it, which is 27. Got it? Okay, I'm going to erase it, and then let me see if I can do it that way. Let me erase that. Keep that up. Okay, so I've got the cube root, sorry, it's the square root of 9, and then we are going to cube it. So that would be 3, and that 3 is cubed, so that's 27. Okay, the next one, I'm doing a cube root of 27, and then the whole thing is squared. I'd much rather square afterwards than square under the radical. It will still work out. So the cube root of 27 is a 3, and then it has to be squared, and that makes 9. Okay, this is a square root of 25, and then we cube it. So the square root would be 5 cubed is 125. The next one is the fourth root, whoops. The fourth root of 10,000. And then we're going to cube it. So I think it's 10 times 10 times 10. 1, 2, 3, 4. Yep, it's 10. And then it's to the 3rd power, so that makes 1,000. All right, so tonight you're also doing this. I think that's all you really need. Let me see what they have. Let's see if there's any more. There's a little bit more practice if you want to look at it and check your answers. It's more of the same. You can do it either way. All right, that's it.